All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause it, and I'll show you what the correct answers are. So this factoring, we're going to have to do a remove, replace, reduce. So I'm going to start by removing the 8 and multiplying it by that 3 to make it a 24. And then you want to go ahead and replace it. And then the numbers that multiply to give us a negative 24 and add to give us a positive 10 are going to be a positive 12 and a negative 2. So then we reduce, if we can, and the 8 and the 12 both divide by 4. So we'll have 2x squared plus 3. And then the 8 and the 2 both divide by 2, and we'll have 4x squared minus 1. Now the second one is a difference of 2 squares, so it'll factor as 2x minus 1 and 2x plus 1. And so this would be your final answer for today. Looking at the math knowledge question, the vertices of a trapezoid have the xy coordinates indicated in the figure below. We want to know the area of the trapezoid. Well, in order to find area of a trapezoid, you're going to use your formula. A equals 1/2 B1 plus B2 times your height. So our height is this distance here. And so basically it's just a change in the y value. But we went from 3 to 6, so that's a change of 3. Now the base 1 or your base 2, doesn't really matter which one you put, one of the bases is going to be that length. And that's the difference in your x values, which is a total of 10. And then the other base down here is a total of 18. So if we plug that into our formula, 1/2 10 plus 18 times 3, we get 1/2 of 28 times 3. 1/2 of 28 is 14 times 3, which is 42. And so that would be your answer there. Okay, so moving on to the lesson. We are looking at lesson 80 today. We're looking at asymptotes of rational functions. So hopefully you'll understand how to figure out where your asymptotes are for your rational functions after this lesson. If the degree of the numerator is less than the degree of the denominator, the x-axis is the horizontal asymptote. So an example of that would be the degree of the numerator is smaller. So we'll put it as an x squared, and that means the denominator has to be bigger than 2. So we'll have some other terms after it, but that would be what it would look like. And if that happens, your x-axis is the horizontal asymptote. So that would be, you'll have your graph, it'll do some stuff, may jump, may do this, but then at the end, it approaches the x-axis on either end. That's mainly what we've been graphing all year long. If the degree of the numerator is equal to the degree of the denominator, then you have a horizontal asymptote that's a constant. And the way that you figure it out, it's the coefficient of the highest power term in the numerator divided by the coefficient of the highest power term in the denominator. So I'm going to give you an example, and I'm going to do a couple more terms so that you can see how this will work. So in this one, our degrees are the same. They're both a 3. And so we look at the coefficient of those two numbers, and we have 3 over 4. And so we are going to have a horizontal asymptote that's going to be y equals 3 over 4. Just like whenever you took the limit as x approached infinity, you remember back at the beginning of the year, we could do a shortcut where we just looked at the two exponents, and if they were the same, it was just the coefficients over each other. That's the same way for this one. So that's going to be our asymptote if the degrees are the same. If the degree of the numerator is greater than the degree of the denominator, we have to actually divide out, usually using long division, but sometimes it'll just cancel. Like if you have an x squared plus 3x over x, then you can just cancel an x in each term. But if you have an x cubed plus 3x plus 2 over x minus 1, you can't cancel each term. You'll have to actually do long division there. So after you divide it out, then you'll look at what is left, and that'll help you determine what your asymptote would be. And so we'll do an example of that in just a minute. So first we're going to start with one where the degree of the denominator is bigger. So find the equation of the horizontal asymptote. It didn't ask us to graph it, it just asked us to find the equation. Well, since the denominator is bigger, the numerator is less, it's going to be that first time. And if you look back at what you wrote, it says that the horizontal asymptote is the x-axis. Well, what kind of equation, when you have it straight across, is that going to be? It's going to be y equals 0. And so that's the equation of the horizontal asymptote, y equals 0. Okay, so let's look at this one. Now we want to actually graph this one. Now, if you notice, the highest power here is a positive x squared. The highest power here is a 2x squared. So since they're the same, we will have a horizontal asymptote that is a 1 over 2. And so we need to go over here on our graph, and we put our asymptote at 1/2. And now I'm going to rewrite it as x times x minus 5, because I can factor out an x in the numerator. And then in the denominator, I can factor out a 2, and I'll have x squared minus 4, which the denominator will factor further. It'll factor as x minus 2 times x plus 2. And now this is like what we've been graphing throughout the year. So we're going to put an asymptote at 2 and negative 2. 2 and negative 2 from those two. And then we are going to have zeros here at 0 and at 5. So I'm going to put a dot at 0 and at 5. And now we're going to graph it. And the only difference that's going to be on this one, we start above the x-axis, because if we plug in something greater than 5, so like 6, this whole thing all of that would be a positive number. And so we're going to start above the x-axis. But if you look, that's going to be right here. It's going to be right above the x-axis, but it's actually below your asymptote. And so it's going to go through that 0 and down towards your asymptote. Now, none of our pieces were squared, so we don't have to worry about jumping or whether we just do a volcano. We're going to jump here. We're going to go through our 0, and we're going to jump again, and we're going to approach our asymptote. Now, I'm sure that you were wondering, what happened here? How were we able to cross that asymptote? Well, the asymptote, the horizontal asymptote, is only as it approaches positive infinity and negative infinity. You're allowed to cross that horizontal asymptote in the middle of your graph, but not on the very ends. At the ends is where it approaches, but around the origin, if you need to cross that asymptote, you are allowed to do so. So it's only for the end points that that horizontal asymptote actually comes into play. Okay? So let's look at another example. We have y equals x squared plus 1. Well, this is one where we want to divide it out. And if I divide it out, I'll get y equals x squared over x would just be x and then the second term would be 1 over x. Now, as x approaches infinity, this term here, 1 over infinity, is going to approach 0. And so our asymptote is really just going to be y equals x. That's what we're going to be concerned with, because that 1 over x, as x goes to infinity or negative infinity, it's going to go to 0, so it's basically going to disappear. So we're going to graph y equals x, and it's actually called a slant. It's called a slant asymptote. So y equals x is just a line like this. And now we have a vertical asymptote at 0, because that cannot be 0. We can't divide by 0. I'm going to do it in a different color so you can see it, but it's going to be on your y-axis basically. And now we've got to figure out, where is our graph going to go? We know that there are no zeros because this won't factor. So that means that it never actually crosses the x-axis. So it's either going to go in this section or in this section, or it's going to go in this section and this section. Well, it can't go in these two sections, because if so, it would be crossing the x-axis. So that means that it has to go in the smaller two sections. And so it's going to look kind of like this. It's going to approach your two asymptotes, and it's going to go in those two areas. Now, if you're not sure, let's just pick a number for 1 and see where it ends up. If I plug in 1 here, I get 1 squared plus 1 over 1, 2 over 1, which is 2. And if I go to 1, 2, that puts me here. And so that tells me that I'm going to be in this section and in this section. So that's another way you can do it as well. Okay, let's look at one more example. We've got x squared minus 1 over x minus 2. So on this one, the numerator is bigger. We're going to have to divide it out, but we can't just do what we did last time. We actually have to do long division. If you want, you can do synthetic division. I'll go over that one in just a minute. We would have x and then x squared minus 2x. You change your signs. And then I have plus 2 and 2x minus 4. Change your signs, and I have a 3. So my equation would be y equals x plus 2 and then plus 3 over x minus 2. If you wanted to use synthetic division, you would use a 2 here in your box, and then you would do a 1, 0, and a negative 1. You bring down your 1. 1 times 2 gives you a 2. 0 plus 2 is 2. 2 times 2 is 4. Add those, you get 3. And you have a 1, a 2, and a 3. Same numbers, okay? Now, on this equation, as x goes to infinity, what is going to happen to this term? Well, we're going to have 3 over infinity minus 2. Infinity minus 2 is still infinity. You can't subtract 2 from infinity. You still get infinity. So 3 over infinity basically goes to 0. So this disappears. And you're left with this equation here, y equals x plus 2. So we're going to graph that line. If we can, we're going to try and figure out some other asymptotes and zeros. Looking here, we have an asymptote at 2. So I'm going to go to 2 and put an asymptote. If you look in your numerator, this will factor as x minus 1 times x plus 1. So that means that I have a 0 at negative 1 and at 1. Negative 1 from this one, and 1 from that one. So now do you see where your graph has to go? It has to go in this section. And it's also going to go in this section up here. And so using our zeros, we were able to figure out which section it goes in. If you want, you can plug in a number into your equation and get a point, and that'll help you know which section it goes in. So that's always an option as well. So those are the 3 types of asymptotes whenever you have rational functions. You have to look at the degree to know what you're going to do there. All right, so you do get to omit number 21 on your homework, so make sure to do that tonight, and then we can go over it tomorrow.